faster than we'd like. Although, from Beth's comment, you know, it'll be a few billion years in the future. I'm not sure. So I hope this was sort of an enlightening thing of how we know what we know. I appreciate your patience in sitting through this lengthy physics lecture. It really was physics. I just put the pretty pictures in so I think it's astronomy. And I thank you very much for inviting me to speak to you tonight.
So you guys are sort of peppering her with questions. If you have another quick, you know, or a few questions to ask her real quick, or if you just want to get up and get some beer.
Why doesn't somebody give me
or
some
something.
beer?
That was a good time to do it. That was a good time.
Yeah, real quick, can you give us a sense in general terms on the forefront, the cutting edge of your world of research? When something happens, when someone discovers something, is everyone on the same page, or how much disagreement is there on?
So let me just give you a perfect example is dark matter, right? So over the last, I guess 3 years, there have been a couple of experiments, and this isn't really out there, but it's I think an example of it. There have been a number of experiments that have announced that they think they've seen direct, they've made a direct observation of dark matter. And part of it is based on sort of this annual modulation of the signal, that you'd expect a different signal when you're moving this way as opposed to this way around the sun, so a slightly different signal in the summer versus the winter. And so a couple of groups have reported that they've seen this annual modulation. Well, there are a number of reasons you could have this type of modulation, including, I mean, these experiments are deep underground, including actual changes in ventilation patterns that happen in the summer versus the winter. And these experiments are so sensitive that this change in ventilation can actually have an effect on the shotcrete walls that are in these mines and can pull out more things that could give you a false signal. So, and there's a perfect example of one group is saying, look, we think we've seen it. And a lot of other groups are saying, you know, we don't think you have because you have some flaws in your experiment that you really haven't quite explained.
But as time goes on, do you expect consensus to be achieved? And is that the pattern that you observe?
Yes, yeah. So eventually, you know, if they can then say, no, look, we've taken, we can account for what you think are creating errors, you know, and then somebody else repeats it. That would be good, but you know, a single experiment, especially when it's something like this, where if you confirm it first, it's probably a Nobel Prize. You know, there's a lot of people that want to be the experiment that confirms it.
Going to your color temperature of different stars.
Yeah.
Now, presuming everything came from the same, you know, Big Bang, but the question is, aren't stars made up of different matter or fuel, and therefore burn at a different or
Yeah,
different intensity?
exactly, and in fact, that's the reason there's stuff down here and up here. And so what this represents is this represents stars who are sort of living their normal lifetime. And so you're right, big stars are hotter, they burn faster, and they get rid of their fuel more quickly. But if I see a hot, big blue star up here, I know how bright it